We're talking about your electrons. So we talked about periodic table last unit. We're going to move that further into electron configuration. I know we touched a little bit on it. We've touched on the electron over the last 2 units. We're going to go a little bit more into it so we can start getting into reactions and things along that line. So when it comes to electron clouds, so remember we've talked about how we have the Bohr model, we had the plum pudding model, and the electron cloud model. The important thing to know is that the nucleus gives it its physical properties, the electron cloud gives it its chemical properties, so the ability to react with things. So we talked about Rutherford's planetary model. It could not explain the chemical properties. The Bohr's model couldn't do exactly that either, but it would propose moving in a specific paths and orbits around the nucleus. This could give us an indication of chemical properties and how reactive a substance is, because if we see these specific orbits, we can see that the planetary model doesn't work as well as this model does. So Bohr's model actually could make an explanation for the chemical properties of an atom. So each level has a specific energy associated with it. So the closer it is to the nucleus, the harder it is for an electron to leave it. The farther away it is, the more likely an electron is to bounce between atoms. So electrons can move from one energy to a level, but that requires a certain amount, which is called a quantum, of energy. And we've talked about it in the past about how the movement of electrons is visible through light. So we see a different change in light based on the movement of electrons. So Bohr's model shows that the higher energy levels they require less energy to move. So your first energy level ends with 2, and then the second is 8, and then the third is 8, and it goes on from there. So the closer it is, so the two that are closest are least likely to leave this atom or move from another level because of that more magnetism to the positive nucleus. So remember we talked about magnets, how the closer you are to a magnet, if you have metal on you, the more likely that metal is going to attract to that magnet. Same thing goes with electrons. So the closer the electrons are to the nucleus, the more likely they are going to stay there. So they won't move as much. They require a lot more energy to go. So Lewis dot and Bohr diagrams, we can do Bohr diagrams based on what the number of valence electrons we have. We can do Lewis dot according to valence electrons as well. So group 1 and 2 have 1 and 2. Group 13, 14, 15, 16, 17, 18, just take off the 1, and that tells you how many valence electrons you have. Now, our transition metals are a little bit different. Those you would have to count out, and there are exceptions to the rule in those as well. So Bohr diagrams go like this. You tell me how many positive, so how many protons we have, how many neutrons we have, and then you draw the energy levels from there. As you can see, 2, 8, and then we have 3, meaning that we are doing aluminum, because aluminum has 13, 13, 14. So that makes sense. So that's how we do a Bohr diagram. Now, Lewis dot diagrams, our notations, are much easier to do because you're just taking the valence electrons. So you're taking the symbol and you're doing the valence electrons. So this means that for aluminum, there are 1, 2, 3. You would do Al 1, 2, 3. So fluorine has 7, so you see 7. You have sulfur with 6, there's 6. Helium has 2, it has 2. So that's how we look at our dot notations. So other examples are you have nitrogen with 5, chlorine with 7, depending on which ones they are, and then of course aluminum with 3. Depending on how many valence electrons you are, that tells you how many dots there are. It is that simple. So when we do a Bohr diagram, we basically make a Bohr's model of the atom, and when we do a Lewis dot, we just do the valence electrons. So if you need to do the Bohr's to get to the valence, just so it's easier for you to count out all the electrons, because remember, Your first energy level is 2, second is 8, third is 8, and it goes on from there. All right? So that is your introduction to the importance of understanding the electron cloud model. So Bohr model and electron cloud model will work relatively close together in this unit. And that is all for today.